Good morning. As I have explained, external memory interfacing, that is how to connect address pins, higher order, lower order address pins, and control pins of memory. So in this video, I'm going to explain memory decoding. Unused address lines are used for memory and decoding. What is the memory decoding logic can be applied? Okay. So as you know, CPU provides address of the desired data and decoding circuits locates the selected memory address, memory location. So as you know, memory chip is activated using a chip select or chip enable pin. And the procedure we followed to connect external memory to 8051 are: first we connected data pins of 8051 to data pins of memory, and then control signal RD bar is connected to read control or output enable of memory chip, and similarly WR bar is connected to write control or write enable pin of a memory chip. So and then a required lower order address lines of 8051 are connected directly to the memory chip address lines, and then higher order address lines are used with the logic circuit to activate a chip enable or chip select of memory pin. Okay. Here we use a simple NAND gate decoding with the NAND gate. So as you know, the lower order address for RAM we used A0 to A12. So the remaining higher order address lines, that is A15 to A13, are used to select the generator chip select signal. That means this in binary these are the addresses. So and the address range is all, A0 to A12 is used as a lower address, no, all zeros to all one. This is the start address and this is the end address, and remaining these three pins are not used. We can make anything like that. So if I make all all one, then the start address in hexadecimal, the start address becomes first 4, it is E0, then 4 bit 0 0 0, E002 or F11. So FF, this is the address range, E000H2 FF. So here these are the unused address lines. Now A13 to A15 are unused and they are used for decoding logic. I have set this as 1 1. I have set this as 1 1. So here by using a simple NAND gate, I'm just connecting that A13 to A15 as input to the NAND gate, and its output is connected to chip enable. So we know this is active low. So whenever the output of NAND gate is 0, it is activated. Otherwise, it won't be activated. Since here all inputs are 1 1, no? All inputs are 1 1. No? So when all the inputs to the NAND gate is 1 1, its output is 0. It enables chip. Okay, this is a simple decoding logic using NAND gate. So and this is the complete diagram. Okay, so in a question they may specify this is the required address range. If the required address range is 40H to 1 triple FH, that means in binary 402, 16 zeros to here 1. So in binary it is 0001, the remaining are 1 1. Observe, these are the unused. What is the values of unused address pins in this address range? They are 0 0. So while connecting these to a NAND gate, we should connect through NOT gate. Let's say this is the diagram. Through NOT gate, because when A13 to A15 are 0 0 and corresponding NOT gate outputs are 1 1, then its output is 1 and it enables the RAM. Suppose if the address range required is 400H to 5FFH, that means in binary, this is the one. First 4 means 0 1 0 0, remaining are zeros. Next 5 means 0 1 0 1, the remaining are 1 1. Again here unused, this is the. So observe, if the address pin value is 0, that we pass through a NOT gate. If it is 1, it pass as it is, because To get output of the NAND gate logic and NAND gate 0, its input must be all 1 1. That is why to make A15 1 and A13 1, we pass these through NAND gates. So this is the control logic, memory decoding. Okay. So here A13 is 0, 14 is 1, 15 is 0. So this is A14 is connected as it is, and this connected through a NOT gate, so its outputs are 1. So it enables this. Okay. This is how simple a NAND gate can be used for decoding purpose. So we can also use a decoder, address decoding using 74LS138. It's an 3:8 decoder, or a 3x8 a decoder. Okay, it is a decoder with 3 input and which generates up to 8 up to low outputs. That means it is a pin description of, block diagram of 74LS138. These are the enable inputs. It has 2 active low enable input and 1 active enable input. I have connected these two, active low enable input to 0 and active enable input to 1. Okay. And VCC to 5 volt and ground to 0. Okay. And these are the active low outputs, Y0 to Y7. And these are the input ABs. To this input, we connect unused address lines, that is A13. Okay. A13 is LSB. A13 is LSB and A14 and A15. So here A is LSB, next C is MSB. Okay. Suppose if it is 0 1 0, that means it is 2. Okay. 2 means Y2 will be 0, remaining all 1 1. Y2 will be 0, remaining all 1 1. Then this Y2 is connected to chip enable. Connected to chip enable. So the address range becomes, this is the one. See, here unused address lines 0 1 0. It is same up to the last address, and here the starting 12 zeros to remaining 13 zeros, 1, 13 zeros to 13. So in hexadecimal it is 400H2 5F. Similarly, if we require the address C000H2 DFFF, so in binary this is the one. Okay. And observe again here unused bit address is 110. Okay. So that means A15 is 1, A14 is 1, A13 is 0, 110. If this is the case, see 110 means 6. So it select 6. Y6 will be 0, remaining all 1. Then Y6 is connected to chip enable. Y6 is connected to chip enable. So this is how. So we can have 8 different address ranges. If we use 74LS138, we can have 8 different address ranges. So this is address decoding using 74LS138. Okay. So see, one more question appeared in the exam. Show the NI schematic interface of 8K external RAM data to 805. Only RAM. So procedure everything is same. Only here we consider only RAM. We are not consider RAM. Same procedure. Okay. Address bar data lines are connected to data pins. We use latch, and same address bar data pins are connected to as input to the latch, and here is connected to latch enable. Output enable is always ground, and outputs are connected here. There's a lower part, and higher address lines A8 A12, they are connected to A8 A12 of microcontroller, and read bar write are connected to read bar write of memory, and here decoding. So here unused address lines are again 3 address lines. Okay. So suppose if we want the address range 400H2 5FFH, we connect like this. Okay. So and don't forget to connect external access to the ground. And see this question, it is asked to connect both 8K external RAM and 16K RAM. 8K RAM, 8K ROM, 16K RAM. So first part of the connection is same. First part of the connection is same. And coming to the second part, since it is 8K up to 12 address lines. See this 12 address lines. A8 to 13 address line. No? A8 to A12 are connected to A8 to A12 of microcontroller. But for 16K RAM, we need one more additional. So that is connected here. That is connected here. The remaining connection as it is here. And here unused address lines are A14 and 15. Only two unused address lines. So they are used for decoding logic. Decoding logic. Okay. Only A14 and 15 is used. If it is 1 1, its output is 0 and chip is selected. So the address range becomes, so these are the unused. So C00H2 FFF. Okay. And see this question only with the need diagram show interface of 8K ROM used for data. See, remember here, ROM memory, read-only memory used for data, not for program, not for program. Okay. So same connection, lower part is same, lower part is same, and higher part. See, so in the previous when we used it for program memory, PSEN bar connected to output enable and chip enable. But here output enable is connected to read pin. Output enable is connected to read pin because we need to read data. Since it is a data, chip enable is connected to decoding logic. Decoding logic. And those are the unused address line A13 to A15. So if it is all 1 1, this is the address ranges. Yeah. So based on, some small explanation. We need 13 address lines. The remaining 3 address lines can be used with the NAND gate to generate the chip select. So since it is ROM, PSC signal is not used for output enable. Okay. RD signal is because it is a data RAM, not program RAM. Okay. So output NAND gate is low and A30 T15 are 1 1. Therefore, the address range is E00H2 FFFH. Okay. So this is how based on the questions you need to write the answer. Yeah. Okay. I'll continue next video. Thank you.